In this video, we're going to look at some 3x3 systems, and we're going to look at how we can determine whether or not we have an independent solution, so our matrix will be consistent, a consistent dependent solution, which is when we can't find one unique solution, or when we have no solution. So I'm going to go with one of each case, and to save time, because that's the focus, I'm not going to go into how to put these into the calculator. If you have questions about that, I have another video that goes a little bit more in depth into that. So here's our first system of equations, and again, to save time, I've already entered them into the matrix. So what I'm going to do is just to show you, I have it in for A. So I bring up A, here's what it looks like in the calculator. And what I want to do is row reduced echelon form on A. So I do second matrix, I'm going to do math, and I'm going to go to row reduced echelon form, RREF, enter. I'm going to put in my matrix A and hit enter. And I can tell I have a consistent, unique solution because of the ones across the diagonal. In fact, what this tells me is that x equals 1, y equals 3, and z equals -2. So I have a consistent, independent matrix with a unique solution. Let's look at the next case. So here's a new matrix. I have this in at matrix B. So just to show you that. So there's matrix B. It's basically all the coefficients, my augmented matrix, because I put on the vector the solution vector. And I'm going to do the exact same thing in the second matrix. And I'm going to do row reduced, and I got to go to math first, sorry. And then I'm going to do row reduced echelon form. And we're going to do it of matrix B this time. And we're going to see what happens. I'm sorry, we got the row reduced echelon form, I want to do it of B. Okay. So, notice what happened this time. One thing, I've got decimals. If you want to get rid of the decimals, do math, fraction, enter, enter, and it converts everything to fractions. Notice what I have, though. I've got numbers over here. I don't have just the ones across the diagonal. Now, what tells me this thing is dependent, but still consistent, is I have 0, 0, 0, and another 0 all across the bottom. So what that tells me is it's still consistent, it's just dependent, which means I can't find a unique solution. So if I look at what this is telling me x minus 19/13z equals 51 over 13, and so forth. So what that'll look like for my consistent dependent matrix is like this. So I'm going to let z equal z, and then I'm writing my other two answers in terms of z. So I'll solve these for x and y, and those will be my solutions. And that's why we call them dependent, because they're dependent on what z is. Now what we can do is we can put in values of z and get solutions. So that's a consistent dependent. Last one. So here's our matrix. Remember, if there's ever something missing, if there's an x missing, you put a 0 in for it, a y missing, a z missing. Make sure you're always consistent with your matrix. I've already got this in from matrix C. So if we take a look at C, notice in the bottom left corner I got a 0 where there was no x, and then I've got the rest filled in. We'll do the exact same thing. We'll still put it in row reduced echelon form. And we'll look at what the answer comes out to be, because it's going to be, there's going to be something that tells us what it is, whether it's consistent or not. This looks at first sight similar to what we had last time, because there are some numbers over here. Again, if we want them as fractions, we can do math, fraction, enter, enter. And we got all our answers as fractions. Notice this last row, though. I have 0, 0, 0, 1. Let's see if there's anything after that 1. It's just 1. What this is saying is 0 z's equals 1. That would be is basically saying 0 equals 1. That is inconsistent. So if you have zeros for all your variables and then a number in your solution vector, it's what we call inconsistent, which means there's no solution to the system. So that's how we can recognize the three cases from the graphing calculator.